Assalamualaikum everyone. So today we're going to cover the new topic which is etching. We're going to cover two types of etching, which are wet etching and dry etching. So what is etching? Etching is a process where we want to remove unwanted material and leave only the desired pattern on the wafer. So this process is performed many times. It's not only one time. You have to perform several times in order to get the desired design or pattern. So in addition to the deposited film, sometimes we also need to etch with the SI wafer so that we can create the trenches, and the masking layer must be photoresist such as SiO2 or Si3 and 4. So the etch is usually done until another layer of a different material is reached. So let us recall back our topic previously. So usually we have the substrate, and then we deposit film, or we can cover it with the photoresist. After that, the photolithography or lithography action take place. So after that, uh, um, they'll be in the development process. So this one where the etching also will take place, and then finally the resist removal will take place. Okay, so what we're going to cover is the etching area. Okay, the etching topic. There are two types of etching. One is wet etching, which etching is done by liquid chemical. Usually, the material used is acid. So unmasked area are etched away by the chemical reaction through oxidation and reduction. And another one is plasma etching, or we call it as dry etching, where etching is done by exposing the material into bombardment of iron in plasma. So wet etching is a simple and established etching process compared to the plasma. So in wet process, the wafer will be submerged or immersed into the chemical, and exposed area could be etched and washed away. For example, for silicon oxide, hydrofluoride was used, where wet etchers work through chemical process to produce a water soluble byproduct. So if you can see the chemical equation below, so the silicon oxide will react with the HF, and then will create H2SiF6 and water. In some cases, the etch work by first oxidize the surface and then dissolve the oxide. So an etch, for example, for silicon, it involves the mixture of nitric acid and HF. So the nitric acid HNO3 will decompose to form the nitrogen dioxide. Okay, so then the silicon oxide is removed by the previous reaction. Okay, so there is double process happen in the etching process. So here is the example of wet etching. So if you can see, there are three layers, which is the masking layer, which is the resist, and then the silicon oxide and the substrate. So in order to create the wet etching, so all the parts here will be submerged into the liquid etchant. So for example, inside here it is hydrofluoric liquid. Okay, so once it's soluble, so then it will take away the part of the silicon oxide and then form the pattern that we want to produce. Apart from that, buffer also usually added to keep the etchant at maximum strength over use and time. For example, ammonium fluoride is often used with the HF to prevent depletion of the F ion in the HF. Okay, so this called basic oxide etch, BOE, or buffer HF. So the ammonium fluoride reduce the etch rate of photoresist and then help eliminate the lifting of the resist during oxide etching. So acetic acid usually added to the nitric acid and HF when SI etch operation take place. Okay, so this one is to limit the dissociation of the nitric acid. So most of the wet etches etch isotopically. So what does it mean by etch isotopically? Isotopically means the rate of the etching on every direction is the same. Either it is laterally or downward. Okay, so the exception is an etch that depend on the crystallography. So this is exception. For example, some etches etch 111 SI slower than 100 SI. So this is some exception in the etching that depend on the crystallography orientation. So edge bias is the amount of the undercutting of the mask. In wet etching, undercut usually happen. So in undercut is the lateral distance per side under the mask as shown in the figure below. It can be characterized by the etch rate anisotropic A. So this one, you will see the equation later. Sometimes the etcher will attack the photoresist pattern, which causes an edge bias, like shown in the picture. So here is the comparison between isotropic etching and also anisotropic etching. So if you can see, this is what happened after the mask and also the photoresist is placed on the substrate. So after the etching process, so you will see that there is under etching for the isotropic. So this one is because of the isotropic etching of the isotropic etching process. So anisotropic etching is more the direction is more into the depth rather than to the side, okay, rather than the lateral. So this one will be able to make sure that the etching on the inside the substrate is in a good condition and precise without any under etching. Here are some advantages and disadvantages of the wet etching. So for wet etching, damage-free finish to wafer surface where surface morphology is typically smooth and shiny. So it is a fast etching rate, especially for the blanket etch. And then simple and direct etching process, since simple resist can be used as etch mask. The process also occur at atmospheric environment. You don't require the vacuum or any other environment. Cheaper cost compared to the plasma etching. So high etch selectivity easily available for etchants, resist and etch material, and good etch uniformity across the wafer. But the disadvantage will be the isotropic etching and no control for precision etching. Plasma etching or dry etching is a faster and easier way of etching compared to the wet etching. So both chemical and ionic species play the roles. So the mechanism of dry etching is very similar to the wet etching mechanism. First, a feed gas is introduced into the chamber, like you see in the picture below, where the gas inlet there are argon or CF4 or oxygen uh, is coming into the chamber, and then first a feed gas is introduced into the chamber where it's broken down into chemically reactive species to form plasma. Okay, so reactive species diffuse to the surface to be etched and then absorb on the surface. Once the reactive species reach the surface, they move around on the surface. Okay, so this process we call as surface diffusion until they react with the exposed film. Afterward, product of the reaction will dissolve from the surface and then diffuse away through the gas stream. In some cases, the sample's chart temperature is intentionally elevated to increase the volatility of the products. So what are etching species? Etching species are ion like CF3 plus or argon plus, which remove material by ion bombardment. So ion etching is much more directional, so what we call as anisotropic, due to the directional acceleration of the ion by the high electric field. Okay, like shown in the picture here. So now, what is plasma? So plasma is a state of matter which consists of free electron and cation. So plasma most similar to the gases, only that they have the bright color. So most of the plasma is called as ionized gases. So in plasma, high number of electron does not move around in orbit, so it moves freely. So this plasma is created usually when gas is either exposed to high temperature or high voltage. Due to the free electron and cation, plasma can easily conduct electricity and also produce magnetic field. So this nature is the same like what been created by fire and also lightning. So in the plasma etching, the process is anisotropic, where the etchant cannot distinguish between the vertical and horizontal dimension like the isotropic. So this anisotropic can be calculated by using this equation 1 minus depth horizontally over depth vertically. So for isotropic, you can see the picture, they are undercut and under the mask, but for anisotropic, it is a clean, you can produce a very clean etching process. In etching process, there is selectivity. So what is selectivity? Selectivity is the ratio of the etch rate of one material over the other. So for example, the selectivity is ratio of the etch rate of the layer being etched to the etch rate of the mask or the layer under the layer being etched. So etching with high selectivity is supposed to remove the selected layer entirely without harming the substrate and mask. Wet etchers can be very selective because it depend on the chemistry between the resist and also the chemical. Okay, so the selective is given by S equal to R1 over R2. So material 1 is the film being etched, and 2 is the either the mask or the material below the film being etched. So if S is bigger than 1, we can say that the etch has good selective for material 1 over material 2. So for example, etchant should distinguish between the SiO2 and Si wafer. So usually wet etching is selective, so meaning that it can prevent from the etchant to penetrate into the substrate. However, the dry etching, they cannot distinguish between the SiO2 and Si wafer. So the advantages of plasma etching over the wet etching is it eliminates of the handling of dangerous acid and solvent, and use small amount of chemical. It can also produce anisotropic etch profile and high resolution and cleanliness compared to the wet etching. So there will be less undercutting and better process control. So for the disadvantages, some gases released through the plasma etching are quite toxic and corrosive. Redeposition of no volatile compound can also happen, and need for the specialized expensive equipment to perform the etching process. In here I've already also give you some link to the YouTube videos. You can look into the videos for better understanding. The videos is not too long, so it is a good reference for you to look into. Okay, so that's it for today. So we're going to continue further in the next class. Okay, thank you for listening. Assalamualaikum.